It takes a moment to read and understand the context of this question. So, a manufacturer has sold nearly 300,000 vehicles. There are 5 different models. So, for a simple random sample of size 2,000 car owners, what is the expected number? So we're looking for a count, the expected number of owners of Model E and the standard deviation of the number of owners of Model E. So understand what we're looking at. X is the number of owners of Model E, where X is distributed binomially with 2,000 trials, that is the size of our sample, and the success probability is 0.008. And we can find that success probability by literally calculating the percentage of people that bought Model E. There were 2,323 individuals that bought this model out of a total of 297,354 people. So that gives us our success probability. So we have 2 outcomes. They either bought or didn't buy Model E. There's a fixed number of trials, 2,000. But then understand here, we're only selecting 2,000 out of a total population size of nearly 300,000. We are selecting such a small amount of the population in order to form our sample that the 10% rule applies here. And we can act, even though we won't be replacing, we'll be selecting without replacement, we can act as if these trials are independent of one another. We can act as if this probability of success for all practical purposes remains constant. And that allows us then to use the formulas for the mean and for the standard deviation of a binomial random variable. So the mean is n times p. You can get that right from your AP formula sheet. That's 16. The standard deviation then is the square root of n. That's 2,000 times p. That's the 0.008 times 1 minus p. That's about 3.98. So using that same model then in part B, if you are selecting a simple random sample of 2,000 car owners, how likely is it that fewer than 12 owners would be included in the sample? Well, again, we're using the same model as we did in part A, but notice this probability that we want is that the count of owners of Model E is fewer than 12. Well, that means we want to include all of the outcomes, 11 owners or 10 owners or 9 owners, all the way down to 0 owners. So this is the actual probability that we want to calculate. This is the best way to describe the event. And this now is a binomial CDF command. Second variables, again, the binomial PDF command calculates exactly one probability, and I don't want the probability of just the 11. I want to include the probability of 11 owners of Model E, or 10, or 9, or 8, all the way down to 0. So I've got 2,000 trials. That's the size of my sample. The success probability, I've rounded it to 0.008. So the x value I want is 11. I want to include all of the outcomes from x equals 11 down to x equals 0. And there's my probability, 0.216, or excuse me, 0.126. There we go, 0.126. So again, this is not a particularly likely outcome, fewer than 12 owners of Model E, because this likelihood is relatively small, although it's kind of in the in-between sort of area. So, but it's still more than 1 in 10. So this probability I would offer to actually answer the question, it's not particularly likely to happen. However, if it is important that you get representatives of Model E, if you are concerned about this outcome, if you are concerned about this, then you need to choose your sampling method carefully, and that's what part C of this question is about. So the company is concerned that a sample would include fewer than 12 owners of Model D or fewer than 12 owners of Model E. So briefly describe a sampling method for randomly selecting 2,000 owners. So my method needs to include criteria to get 2,000 owners The method needs to be random, and it needs to ensure at least 12 owners for each of the 5 car models. So what I care about most today is that you recognize this is a stratified random sample. So literally, I want to select randomly from the owners of Model A, the owners of Model B, the owners of Model C, Model D, and Model E. And the way I structured this, I decided, okay, I need to divide up my 2,000 subjects or my 2,000 owners between all 5 of these models. So I decided to calculate the percentage, the 112,338 out of the 297,354 owners. That's 38%. 38% of owners bought Model A, 32% B, 28% C, and then approximately 1% each for D and E. And that's going to give me a way to be specific in order to get a stratified sample where I'm randomly selecting from each model, but I'm also guaranteeing that the total sample size is still 2,000. Again, for our purposes right now, I care that you realize that you need a stratified random sample. But in terms of the rubric, it's important you include 3 things. This has to be a random selection. It has to make a total sample size of 2,000, and I need to ensure at least 12 owners of each model will be included. So I wrote 38% of owners bought A, 32% bought B, 28% bought C, and then about 1% bought each of D and E. So if you use these percentages of the total sample size of 2,000, the company should randomly select 760 owners of A. So 760, that is 38% of 2,000. 640 owners of B, that's 32% of 2,000. 560 owners of C, that's 28% of 2,000. And then 1% of 2,000 is 20. So I want 20 owners each selected from D and 20 owners of E. So this results in a sample of size 2,000. So because I'm selecting at least 20 of each type, each model, I've got at least 12 owners of each type for each model, A through E. What's important, though, is that you are randomly selecting these numbers out of each of the groups, A, B, C, D, and E. That's what makes a stratified random sample.